Hello, my name is Anna Maria Pacias and I go to Dove Schools. My project is the hand crank generator. The materials for this project are a hand crank generator, a miniature light bulb, a base, and wires. There are also other materials that you can add if you had money to spend, such as a miniature DC motor, a patch cord, wire coils, a bar magnet, DC voltage supply, a parallel circuit board, a magnetic field sensor, a current field sensor, and a data collection. Before we begin, we need to talk about 4 safety measures. 1. Be careful with magnets as the stronger ones can pinch skin. 2. Be cautious with sharp items. 3. Keep magnets away from electronic devices. And 4. Do not overload sensor. This can be caused by spinning the crank too rapidly and can potentially bust the light bulb. Now, without further ado, let's begin the project. There are a few steps to this experiment. They are: 1. Crank the generator that has a light bulb in order to create light. 2. Crank the generator at different speeds in order to observe brightness. Number 3. Switch the direction in which you are cranking the generator in order to see what happens. As you can see from the video, it works exactly the same. There are 3 main principles to the hand crank generator. Number 1 is Lenz's law. It is named after Heinrich Lenz. This law is much like Newton's third law of motion, which states that every action has an equal but opposite reaction. Basically, what this law says is that if an induced current flows, the direction will always be opposite to the change that produced it. The more current I generate, the greater the force that opposes me. Number 2 is magnetic flux. Magnetic flux is the number of field lines passing through a closed surface. What does this have to do with the hand crank generator? This relates to the generator because it has to do with the coil turning while the generator is being cranked. The formula for magnetic flux is magnetic flux equals B, or magnetic field, times A, area perpendicular to magnetic field B. Last but not least is number 3, Faraday's law. This law is named after Michael Faraday. This law states that when a conductor moves into a magnetic field, electromagnetic field, EMF, gets produced. When he spun a coil of wire around a magnet, he noticed a steady current. This law can be applied to magnetic flux, as it can be calculated through the number of field lines in which the generator is cranked. Up next, we will be talking about my ELA component. In this section, I chose to do a journal. I talked about the many tasks I did for this project. Of course, this journal had to be regularly maintained, as I had to update it every single time I did a new task. I wrote about the little things I had to do in the beginning, and even the more complicated tasks as I advanced into the project. Overall, this project was an enjoyable one. The social studies component was a bit different than the ELA component. For the social studies component, I talked about the many contributions to the hand crank generator's caused. I discussed many important figures such as Michael Faraday, Heinrich Lenz, Anios Jedlik, and Hippolyte Pixii. The effect that those individuals had was vital for the principles that developed throughout history. Although this took much longer than my ELA, I did not have to maintain the social studies component. This component was enjoyable and helped me learn many things about the hand crank generator. The hand crank generator, although still widely used today, has evolved into the type of generators we see today. You know, the ones that power entire cities. The hand crank generator is especially useful during times of natural disaster, as it does not need to be plugged into a wall. Unfortunately, this is the end of my video. Thanks for watching. The end.